All right. Hi, everybody. Can everybody hear me? Is the audio sounding okay? Wonderful. All right. Well, hi, everyone. Thank you so much for joining. It's great to see everybody here, and really happy that you joined. So for anybody who doesn't know me, my name is Dylan Kearns. I'm the author of Elm GraphQL, and I am the founder of a company called Incremental Elm Consulting. And today we're going to be talking about a really fun topic, modeling. Let me share my screen here. And there we go. Okay. So yeah, this is a really exciting topic. We're going to be talking about modeling errors in GraphQL, specifically for Elm apps. And the reason that this is specifically for Elm apps is because, for one thing, when you're using GraphQL from a lot of clients, you're not dealing with a type system on the client side. So, you know, it's very nice in terms of having documentation in your GraphQL, doc explorer that tells you the types of the data that you're looking at, but your client doesn't really benefit from that. But beyond that, there are also some things with Elm GraphQL in particular that that you don't get those benefits from other clients, which we'll explore in a minute. So so along the way here, feel free to chime in with a question at any point. I'd love to clarify anything that comes up along the way. This is what we're going to be talking about today. First, I'm going to be talking about what errors look like in GraphQL and how they're fundamentally different constructs than errors in Elm. And then I'm going to be doing a little live coding to demonstrate some different techniques and trade-offs when dealing with modeling errors in your GraphQL schema for your Elm app. And then finally, we'll have some time for Q&A. So, all right, I don't see any questions at the moment. I'll check in periodically, so feel free to just post a question and I'll do my best to answer it as we go along. So great. So GraphQL errors. If you haven't seen GraphQL errors before, this is an example of one. So we've got this. You'll notice, first of all, that the errors are a list of errors. It's not a single error. So you can have multiple errors for any given GraphQL query, which is quite nice. It's nice to not just, break down in the middle of it and only get one error back. You can get multiple errors. You get kind of the location, the line number, and in some cases the column number, depending on your GraphQL framework that you're using. So that's quite handy as a developer. And it points to the particular field. You get this path, which tells you the specific point in the query that caused the error. And then you get a message. So in this case, name for a character with ID 1002 could not be fetched. So, okay, that's useful, but there are some pretty important issues. So the problem with GraphQL errors is, first and foremost, these are fundamentally untyped pieces of data. We have message, which is just a string. So it's stringly typed. And ultimately, you can look at the path, you can kind of try to associate which field caused a particular error with a message, but it's just a string. So you're kind of scraping data off of that string and trying to create structured data from it. It's a very limited thing. So in general, GraphQL errors are very useful for developers, but they're not presentable to users. And there's another serious issue, which is that it can null out other data in the request. So if you have an error in your GraphQL error, if you send back any GraphQL errors, then you can null out any field in the response and it's valid, even if it wasn't a nullable field. That's just part of how errors work in GraphQL. So we're going to see an example of that in a minute. Some people are saying the audio isn't working, but some people are saying it is working. I'm not sure what to do about that. Maybe it's an issue with, okay. Okay, I'm gonna assume that the audio is working since some people are able to hear it. Sorry for the people who are having issues. Okay, so, all right. So we've got some issues with GraphQL errors. And now let's compare that with errors in Elm. So we have a result type. And in a way, this is a first-class citizen because it's built into the Elm core library, but it's actually just another type of regular data. It's just a custom type where really we're saying, hey, I've got this thing that could be one of two things. It could be this one kind of data or another kind of data. The first, which represents an error state, and the second, which represents a success state. It's just a type of error. You use it just like any other custom type in Elm. You can do a case statement to check what it was and do something with the value for each case. GraphQL errors, in contrast, are sort of a control flow mechanism. So it's more like raising an exception in another language where it fundamentally kind of changes, puts you in a different mode where it's not just one little bit of data. It fundamentally changes the semantics of everything else around it. Okay, so let's GraphQL errors in action here real quick. So I've got a very simple schema here. I've got a little app that, here's my API. So for anyone who hasn't seen this, this is called the GraphQL Playground. This is just, this is not a custom app. This is just a tool that you can use to consume any GraphQL API. So in this case, I've got a little local API that I'm serving up. And one of the fields I can request is a list of shopping cart items. In this case, we've got this product, an Elm bonsai tree, in our shopping cart. And then I've got a field here where I can get some discount information. And then I can get a discounted price based on that. So if I enter the discount code secret, then I get a discounted price of $199. And if I use secret 2, it's $149. But what happens if I have an unrecognized code? Well, in this case, I'm just throwing an exception in my server-side code. So it's resulting in a GraphQL error. Now I'm giving a specific message. I'm saying unrecognized discount code, which is nice. So we could kind of parse this string and maybe search for the word unrecognized on the path discount. And then we could kind of figure that out and show a nice message to the user. But you may have noticed the data coming back here is null, but I was actually depending on this data in my UI for the shopping cart items. So now suddenly my shopping cart that had a little badge with the number 1 for one item in my shopping cart is now empty. I don't know what to do with that. So that's pretty unfortunate, because looking up a discount code and not finding it is a normal code path that I would expect to happen. It's perfectly reasonable for a user to enter a discount code that doesn't exist. That happens all the time. So it's really unfortunate for the rest of the data to become null suddenly. Okay, so that's an example of GraphQL errors in action. So I'm going to give a couple of rules of thumb for how to deal with GraphQL errors, when to use them, when not to use them. So it might be a GraphQL error if only developers should see it. Or if you don't expect it and you want to log it or track it. So in general, this is very similar to exceptions in a lot of languages. It's kind of like a runtime exception is a good way to think of it. It's something that you really don't expect and you don't know how to handle it. You just want to tell the system that something went horribly wrong. And you don't know what to do about it. But rather than being a GraphQL error, it's just plain first-class GraphQL data if a user will see it and if you expect it. So if you're testing it, if you're going through your shopping cart application, and you would, when you're testing it, you would test a valid discount code, and you would also test an invalid discount code or an expired discount code. Those are expected code paths. Then those really deserve to be first-class GraphQL data. So I'm going to do a live demo to kind of demonstrate how to model those error states as first-class GraphQL data rather than relying on the GraphQL error mechanisms. Are there any questions so far? Feel free to just pop a question in and I'll check back occasionally and see if there are any questions. Okay, so now I've got another type that I'm representing in my schema here, which is called discount or error. So with discount or error, this is actually representing this is represented using a GraphQL union type. So now with the GraphQL union type, we can actually see the type I'm getting back here, but I can't get any data. The reason that my auto-completion here isn't giving me anything except the type name is because the type name exists on any type. But if I'm doing a union type, I have to do essentially the equivalent of an Elm case statement here. So the way I do that is I'd say, if it's this type, if it's a product info type, then I want the discounted price. And if it's a discounted lookup error, then I want, and the only field I have on here is the reason. Okay, so now I've got my meaningful data coming back. So I look up discount code secret and I get a discounted price. So I do indeed get this type of data. Now let's have a discount code that doesn't exist. Notice that the reason is coming back as not found. And if I put the type name back in here, you'll see that it's a discounted lookup error. So we're getting this different type. So let's look at how this type looks in our little documentation viewer here. So we've got discounted product info or error. That's just the name I've given it. So it's a union type, which is going to be either discounted lookup error or discounted product info. Now, the way that union types work in Elm is quite different than the way that union types work in GraphQL. In GraphQL, you union together two different types of objects. I'll talk about that a little bit more later in the webinar, but let me do a little bit of live coding here to show what it looks like to handle these union types that represent these errors in Elm GraphQL, in some actual Elm code. So, all right, let me pull up my query viewer here. So this is just kind of showing me the query that I'm running on the right here, and the Elm data that I'm getting back once it parses the GraphQL response. So, all right, let's get Now, why don't we start with just getting the discount, the endpoint that's actually giving us back a GraphQL error when it fails to look it up. Okay. So I need to change the type here. It's giving me back an int. And I get back the discounted price, 199, in the case that I successfully am able to look up that discount code. And if I look up secret 2, I get 149. And if I look up something that doesn't exist, then I get a GraphQL error. So again, very useful for a developer. Not so great for actually modeling the possible data states that we expect in a reliable, type-safe way, which is what we're looking for here. So let's do that. So I'll just store this off in a little top-level value here. So I'm gonna do query.discount or error. This is my endpoint that uses the union type to model the error. And why don't I just copy paste this for now? In a minute, I'll show you some techniques for building it up easily, but first let me just give you a demo of what this would actually look like. So what I'm going to do here is I'm going to model this. I'm actually going to use a GraphQL result. So I'm going to map it into a GraphQL result. So let me break down what I'm doing here. So I'm using this helper, which this is just how you do union queries using Elm GraphQL. So I've got my union type, api.union.discountedProductInfo or error. That's just the module that has the generated code for that GraphQL type in my Elm GraphQL code. So I use the generated code. It's got this .fragments. And .fragments is what I use to grab these little dot things in GraphQL terminology are called fragments. So this is the equivalent of saying, in the case that it's discounted lookup error, give me the reason. In the case that it's discounted product info type, give me the discounted price. So I'm saying on discounted lookup error, I want the reason, but each of these different fragments needs to map into the same data type. So I can't just have one give me an integer and one give me another type. I need them to map into the exact same type. And one way to map them into the same type is just to map the one version into an error and the other version into OK. So what I end up with is a result type where the error of that type is a discount error reason. And then the success type of that is an integer. So are there any questions? Let me check and see if anybody's asking any questions. Are there any questions so far? We just covered a lot. What happens if you get a real server error? Now, the selection set.map will map a list of errors into a single error. Gotcha. Thank you for the question, Kyle. Right. Okay. Great question. So, so the question was, what happens if the server gives a 500 or an error? And the answer is that while I'm calling these errors, I'm saying I'm mapping this data into an error. I'm mapping this data into an OK. So I'm representing it as this GraphQL result type, which represents a type of operation that could fail. It's actually just data. It's just first-class GraphQL data. So if I give back, if I look up a discount code that doesn't exist, I get back this error not found. This is not a GraphQL error. This is GraphQL data. And that GraphQL data has error in the name because I'm modeling error. But it's just custom GraphQL data that I'm defining. I'm defining it to model my own errors that I expect in my application. Now, what happens if the server throws a 500 response? It certainly could at any point. A mouse could chew the cable, and there could be a timeout error. There are all sorts of ways. We can't predict every possible error that the server could give us. It could give us an error at any time. But the point is that we want to model the errors that we expect, and then anything else. Sure, we can't predict the future. We don't know what possible errors might occur, but we model the errors that we expect using first-class GraphQL data, and then everything else is an exceptional case, and we figure out how to deal with that. So maybe we can recover from that, and we have a code path for that, or maybe we can't recover from it, and we just say, oops, something went wrong. Please try again in a few minutes. Okay, Kyle is saying, will we still know about more unknown HTTP? So Kyle, did I address your question? Right, okay, it looks like I did. Excellent. Okay, great. Awesome. So if there are any other questions, feel free to post them. Are there any questions about union types in Elm GraphQL and what we kind of did here for this kind of fragments selection we did? Nope, not seeing any questions. Okay, cool. So let me talk about one other detail here, which is kind of nice. So one thing I haven't touched on yet is how I modeled my discount error reason. So I've got a data type, which is a union. And so I'm combining together these two different pieces of data. Either I have my discounted product info, which at the moment it just has a discounted price. Maybe it might have some other metadata about that discount code, like when that discount started and when that discount code stops being valid. But for now, I've just got this little bit of info discounted price in it. So I've got a union that's combining together this object. It could be a discounted product info, or it could be this object, a discounted lookup error, which has this little piece of data, reason. Now let's look at the type of reason. This little discount error reason is an enum that I've defined. And in GraphQL, an enum is just a simple list of possible discrete states. So it's like a type safe string. It's like a string that can have n values, and you know exactly what those values are up front. That's all it is. They also have documentation for each of them, which is quite nice. So you can create quite a nice user experience for the developers using these enum types. So we've got expired, over limit, and not found. These are just the types that I've defined manually. You can define them however you want for your own application. I was speaking to somebody last week about modeling GraphQL errors using the Stripe API. So when you're making payments with Stripe, if you go to the Stripe documentation, there's a page with 20 to 50 different possible errors. The payment was declined. The expiration date of the credit card was expired. And they were all just error. These are what these different error codes describe. And so we talked about how to model that GraphQL, that using a GraphQL server. So when you make a request to make a payment using the Stripe API behind the scenes, we could basically copy paste all of these different error codes and what they represented and define a GraphQL enum type. So that's quite a cool technique. Okay, so that's more or less what I wanted to cover in the live demo. So just a quick note, some other examples, some cases where modeling GraphQL errors comes up quite a lot is form validation. So so what's the right tool in your toolkit? Do you want to use a GraphQL error, or do you want to use first-class GraphQL types to represent your different error states? Well, to answer that question, I think you need to ask yourself, is it an exceptional state or is it an expected state? If it's an expected state, then it's really nice to model it as a first-class GraphQL data type, because then you get all the type safety and reliability that comes with that. Now, there are times when it doesn't make sense to do this. So for example, if you're doing form validation and maybe you're checking if a username is unique, so the server needs to interact. So maybe you have certain validations. You say, okay, the username must be, no more than 20 characters and no less than 3 characters. And you say that your date of birth must be at least this date. We need to check that you're over 18. These are things that can be checked on the client side. And so we don't necessarily want to model these as GraphQL errors in our schema, because we expect the client to check these things. So really the best way to deal with that is to let the client check those things. We trust the client. And of course, it's possible that these things will somehow not be checked. Maybe somebody is directly hitting our endpoint, right? It's just, it's the web. We can always hit the server and get around the JavaScript code. It's not foolproof. So the server needs to have server-side checks, but we don't need to model those checks because it's not an expected path. It's sort of an exceptional path. Okay, a user went and they manually submitted the data to our endpoint instead of going through our UI. Whatever, we don't really care. We're just going to give back a GraphQL error. There's no point in modeling that because it's an exceptional case. On the other hand, if you have a unique username check, that's something that will fail very often. So you don't want the page to just break, or you don't want to be dealing with the second-class data type of a GraphQL error when something goes wrong that you expect it to go wrong, not having the username be unique. So in the case that only the server is checking for the username being unique, I would recommend modeling that as a first-class GraphQL error because you expect that to happen. Now, on the other hand, if you're checking for the username being unique, on the client side, you're asking the server, hey, is this username unique, before you submit it. There could be some race conditions. Perhaps the user checks that a username is unique and then they wait 20 seconds. And then in that 20 seconds, somebody goes and grabs that username before them. There can be race conditions, but that's kind of an exceptional case. So it might be okay in that situation to model it without using a custom error type, just throwing an exception on the server and having a GraphQL error. So you've already checked it, so it's exceptional for it to fail. So it's okay to use a regular GraphQL error instead of a custom data type. Another case where a GraphQL error might make sense is authentication. So we have HTTP response codes that represent authentication errors. So it's reasonable in situations like that to actually check the error code since it describes that specific problem. All right, so that's it at this point. I'll open it up to your questions about GraphQL error modeling. Thank you so much. All right, so let's see. Okay, great. So Zvi, I hope I'm pronouncing your name correctly, posted a question here. Oh, sorry for the infinite recursion. I'll look at it on this screen. What's the advantage of using unions in the schema and fragments on query versus just using regular fields, i.e. add both fields for result and field for error? Right, so if I'm understanding the question correctly, then Zvi is asking, why don't I just have a field that gives back the error? So add a field for the result and add a field for the error. So what can happen with that is, first of all, you'd have to represent your the data back. So in this case, like the discounted product info, I'd have to represent that as a nullable field because it could not come back, which I certainly can. I certainly can model field, and then I can have this sort of contract where it's like, okay, I'll either have, you know, let me just type what this would look like out here. So I could say, you know, I've got an object called, you know, discount product info, and I've got the discounted price, or maybe I have like the details, and the details is the discount details, and I'm not putting an exclamation point here, which means that it could be, and then I've got an error, and that'll be a discount lookup error. Okay, so what that means is these are two nullable things. And so I'm going to get back a response that either has details, which is which has the discount price of $149, or I'm going to get back some data in my JSON response from my GraphQL query that is an error, and that error has the failure reason or something like that. And in that case, the discount price will be null or undefined, and then vice versa. This will be null in this case. So I certainly can do that. One of the problems with that is that the you don't have to check for it. So there's nothing preventing you from just grabbing the discount code and then saying maybe with default, you know, the actual. Now, it may be that it's a reasonable way to model it, just having it be a nullable field, and then, you know, that does the trick. So it really, all of these data modeling things, they're just tools in your toolkit that allow you to kind of express the constraints of your domain. So one thing that's very cool for union types, just as with union types in Elm, when you add a new case to your union types, then it suddenly starts to fail. So for example, in this case, we've got our union where we're looking up, you know, if it's a discounted lookup error, then grab this data. If it's a discounted product info type, then grab this data. Now, if I added another possible type to my union here on my server, regenerate my Elm GraphQL code, then suddenly my code is going to stop compiling and tell me, hey, you need to handle this other case, which is quite cool. So, so in a nutshell, why use a union in GraphQL versus versus giving back two different knowable fields? You know, the same reason why you would use something like remote data in Elm. It's just a really nice data type that nicely expresses these states. If you're not familiar with remote data, check it out. There's a nice blog post on it. Union types or custom types in Elm are just really nice experiences and great ways to model data. All right, and Martin is asking, how about when a user is authenticated but not authorized to view a certain field? How would you model that? Yeah, that's a great question. That's a bit of a can of worms because it's a very complicated topic, and it really depends on your domain. So I would say if you one particular resource, you know, maybe like maybe an admin console that you know is going to fail in some situations if you're not authorized, or you know, if you're not authorized to view that resource, then it could be nice to model those possible states using this type of technique. It's definitely a little more cumbersome than just throwing an exception and having a GraphQL error. So, and you know, we have 401 unauthorized to express that. So I would say it's pretty reasonable to just have 401 unauthorized, unless it's really baked into your domain that you want to give very specific feedback to people why they don't have access to a particular resource, and it's a common code path that, you know, it really becomes a user experience question. How fine-grained do you want the feedback to be to your users when they're not authorized to access something? In the case of GitHub, if I go to github.com/dylankern/Elm GraphQL secret repo, then I get a 404, not a 401, because now, well, actually, it turns out this repository doesn't exist, but if it did exist, you would also get a 404, because you don't want to reveal information about which resources exist versus are not authorized. And so often it's good enough in terms of the user experience to just say, like, I can't give you that. And I'm not going to give you details about why. So it comes down to the user experience you want. How many details, how much feedback do you want to give the user, and model your data appropriately. Peter is asking, can you come up with a good name for an error that's encapsulated in a data type? Can you come up with a good name for an error that's encapsulated in a data type? Okay, so Peter, help me make sure I'm understanding your question correctly here. So are you asking about having, for example, our discounted lookup error? Are you asking, could this thing in itself just represent an error, and could I just have a different object representing each error? Oh, okay, thanks for clarifying. Just a name for the technique. Awesome. Error union. That's a good question. Yeah, errors as data, I like that. It's modeling, I would say, you know, maybe call it like a first class, you know, first class GraphQL error as data. I don't know, you know, GraphQL errors as first class data. Type safe errors, yeah. We'll have to play around with that. Let's experiment with that on Slack. Cool. All right. Oh, and Jonas has a question here. Is there some prior art to handle errors like that in the GraphQL ecosystem? Do you have plans to make this first class in GraphQL? Ah, interesting. I'm definitely open to ways that we could make that a more first-class experience. I mean, to be honest, this is, to me, this is pretty nice to just say, hey, I've got, I want to grab this data and then wrap this in this error type, and then wrap this in OK. So this is the error case. This is the OK case. That's pretty easy to explain, and you could factor this out into a nice module and a nice helper. I'm definitely open to ways to make this better. One of the things that's really interesting to note here is that with GraphQL, you can't model. So let's take the remote data type here, maybe. So like, here's a union type in Elm, remote data type. So we've got this type. It's either an error. Let's just name this to be more. So we've got this remote data type, and notice that in Elm, custom types, also known as union types, are specifically a tagged union, which means the first piece in each of these variants is the name, and then what comes after it is the data. So we have not asked. That's just a tag that represents that thing. Loading failure, and then failure takes an argument of the error data. Success, and then success takes the argument of the value. So compare that with something like, in a language like TypeScript, for example. I don't remember the exact syntax, but something like, I could define like int or string to equal, I guess they're numbers. But I could have like number or string could be either a number or a string. And so there's not a tag associated for each of them, right? In Elm, if I wanted to define something like that, I'd have to say int or string is either my int and then it has an int, or my string and then it has a string. So I have to kind of define the tag before the actual data type. I can't just mush together two different data types. In GraphQL, it's the kind of mushing type of union. It's an untagged union, as opposed to Elm, which is a tagged union. So, so that's kind of interesting, because then what if you have a few different error states that don't have data associated with them, and then you have some error states that do have data associated with them? So when you're dealing with a bunch of possible error states that don't have data associated with them, it's quite nice because you can model it with an enum in GraphQL. And when you have a GraphQL enum, so I'll show you an example of this GraphQL enum. This reason here is a GraphQL enum. So if I look at this, here's the definition. This is auto-generated from the type I defined on the server. So again, on the server, we saw the discount error reason is an enum that's either expired, over limit, not found. If we look at our Elm code, we have a type auto-generated for us that represents those possible states: expired, over limit, not found. And that's quite nice. But then what if we have some error states that don't have data associated with them, and other error states that do have data associated with them? So if it's expired, maybe we want to give the expiration date. If it's not found, maybe we don't want to give any data at all. So that gets into a little kind of fuzzy area of what the best way to model that is, but we could model that. We could certainly model that by having like our, we could have like a not found object in our GraphQL schema, and that object could just have, no data associated, and we could just have this be, I don't know, some like nullable data. It gets into a weird situation because you have to put some data there because objects can't be empty. You can't have an object that has no data. So it's a little bit awkward, but you could do something like this where you have like an object for not found, an object for expired, and you could have, expired at, something like this. And then you have your union, which is just, again, your discount lookup error is either expired or not found. So it just mushes together these objects. So you can either do it that way, or you could have all of your sort of untagged ones be like an enum. So you could have like an enum that's like not found or over limit. Now the problem is, now you have to create an object that uses these. So you have to have like an untagged error. That's not a great name, obviously, but then you have the reason, which is this type. So it can get pretty awkward, but I think the main thing here is it might be awkward, but it is type safe, and we are consuming it from Elm. So if it's type safe and we're working with Elm, I'm feeling pretty good. No matter how awkward the data modeling is, I'm going to prioritize type safety pretty highly, because when I know that my generated code is ensuring that I'm handling all these possible cases and I've got the correct data that my compiler is aware of, then I can abstract it away using Elm modules. I'm not worried about that. I can deal with that. I just want it to be type safe, and I just want to have first-class type safe error data. That's my main concern. All right. Great. All right. Well, it looks like I got to all the questions. So again, thank you for attending, and stay tuned for more webinars in the future. Thanks a lot. Bye, everybody. Feel free to ping me on Slack and keep the conversation going. Thanks, guys. You too. Have a great day, Ilya. Thanks, Martin. Appreciate it. Thanks, Jonas. I hope that answered some of your questions about modeling error in Elm GraphQL. All right. Take care, everybody. See you later.